So let's start this lecture. In this lecture, I'm going to continue on the topic of dynamic traffic assignment. In the last lecture, Patrick mentioned that in vSim, in vSim, it's not really doing dynamic traffic assignment because its assignment is using the same algorithm as those were used in static traffic assignment. So it's a fake dynamic traffic assignment in a sense. Actually, most simulation software or packages are not using the real dynamic traffic assignment tools. They only do static traffic assignments per intervals. So I don't know if you can understand, but I just want to mention it. Here is the notice of the day. First thing is, in the last homework, some of you mentioned you couldn't use the dynamic traffic assignment tool in the 30-day full trial version. So please contact me after the class if you don't have access to the full license. And we can arrange a time and a computer so you can use it. The second thing is Thursday's class is canceled. I think this is good news for you. And the reason for that is I know that you have a lot of homework or review to do because you are going to have other classes midterms. And I want to give you more time to think about your project proposal. But the midterm is due. Midterm will be within 2 weeks. It will be next Tuesday. And this midterm, I want to make you relieved, so it's open book. But don't bring your laptop, and don't talk to each other, of course. And there will be a review lecture before that, on the Thursday, before that Tuesday. So I want to help you in a review lecture. I want to tell you which part should be emphasized. And this review lecture, in this review lecture, I'm going to talk about all the previous homeworks. Although the homeworks have nothing to do with the midterm, I want to talk about that a little bit. The fourth thing is the project proposal is due on October the 25th. We now have a candidate, which is called calibration of a large-scale transims model. This is the model that we are now working on, and it has some problems. And if you are interested in calibrating it, it can be your project. Otherwise, you can have your own topic. If you want to use your own topic, be sure that before you submit your proposal, talk to me, discuss with me first. Okay. Today's outline is, it has only one thing, transims DTA. To introduce transims DTA, I have first to talk about the tools in transims that we use for DTA. Then we are going to talk about the feedback procedures that are used in transims. And I think this part is the most important and most difficult part in the whole semester. So pay a lot of attention to it. And if you don't understand any part, just let me know. Otherwise, you won't understand the rest. For transims, I first want to talk about 3 tools that you have already used in your homeworks. The first tool is called convert trips. The second one is router. The third one is macro simulator. Let's review what it does. In convert trips, we have 3 outputs, 3 inputs. This is the OD matrix, zone-to-zone trip table, OD matrix. This is the diagonal distribution of each OD matrix. For example, here we have from zone 1 to zone 2, 440 trips. And this curve defines the probability that a trip is started at a certain time. For example, a trip is more likely to start at this time than that time. And each OD matrix has a corresponding diagonal distribution, which we call trip timetable in the homework. The third thing is activity location, a table of activity locations. And activity locations have the information of traffic zones. So each activity location has a zone ID. With those 3 data input data, we can run convert trips, and we can generate 4 files. The first one is called trips. The second one is called household. Then we have population and vehicles. And they are going to be used in following steps. This is the table called the diagonal distribution you may have already viewed. And in this table, we have three fields. The first field is called start. The second field is called end. And this field, these two fields, can define a time period. Then the last field is shell, which defines the relative probability. When convertrix is run, this field will be normalized. So all this table is standing for a PDF, probability distribution function. And we have a tool called smooth data that we can use prior to these convertrix. So if this spiky curve is the data we get, and we don't want to use it because it's too spiky, so we can use a tool to smooth it. It's called smooth data. And here is a key in convertrix that I haven't mentioned. When we generate activity locations automatically, they are distributed, evenly distributed along the network. So an activity location can be everywhere. But sometimes when we, for example, here, we have a network, and here is a border link. On this border link, suppose we have two lanes, one for outgoing direction, the other one for incoming direction. And when we use transient net, here will be an activity location, here will be another activity location. And this activity location doesn't have any incoming path to any other activity location. Similarly, this activity location doesn't have any outgoing path. I mean, no activity can go to this activity location. No other activity location can go here, because here is one way. And in this case, we want to define the probability that an activity location is selected when we use convertrix. And that's the key called weight key. We can have two weights, one called the origin weight, the other one called destination weight. And within activity location file, we can define our own weight field. These two fields are not automatically created, but we have to define that. We can create that. And these two fields are representing the weight when we are doing when we are converting trips. And the probability that we are getting an activity location within the zone will be equal to the value of this field divided by the summation of all the activities within that zone. And here are the output of convertrix. We have 4 files. The first file is called activities or trips. And we can see we have vehicles, household, person, trip number, and vehicle, and start time, arrival time, origin, destination. But it doesn't have any information about path. So it's like distribution. This is the distribution. And we have household, synthesizes household and population and vehicles. And these may be later used in macro simulator or router. The second tool I'm going to introduce is router. Router is the dynamic traffic assignment tool in transit. The tool itself is very easy. It's very simple. It's just using time-dependent Dijkstra's shortest path. And it can take several inputs, including link delay. Link delay means the travel time on each link, which can be produced by macro simulator or another tool called blank sum that we will introduce later, which is using formulas, VDF. And router needs the trip file that we just created, household file and vehicle files. These are outputs of convertrix. And it needs the network files. The output of router is one file called travel plan file, which contains all the paths of the trip file. But a special characteristic of router is this file. This is a household file. By default, it contains all the household, but router allows you to specify a subset of the original household file. So it will only do travel assignment for part of the household, and this is very important for future books. And this link delay file can be missing for the first iteration because we don't have the link delay data. But in our feedback, after the first iteration, we then need this link delay file.
Why the diagonal distribution file missing in the input of the convert trip?
Diagonal distribution is the input of convert trips. And OD matrix is the input of convert trips.
Oh.
And these are the output of convert trips. Thanks. And here I listed some helpful parameters. I don't want to explain. I list them here so you may want to reference in the future of router. The output of router is a set of plans. We can use a tool called ArcPlan, which is similar to ArcNet, to visualize these plans. A plan is a polyline from an origin to a destination. So it's the path. A plan stands for one path. The third tool is micro simulator. Micro simulator is the only simulator in transims. So it's the core of transims. And in micro simulator is the second-by-second movements of vehicles are simulated. And the network is called cell-based network or cellular automata network. Micro simulator has 3 inputs. The first thing is the network. Then we have the vehicle file that will generate